Got it. Okay, cool. So this is where we left off last time. We were talking about basically the uterus and its job of, being able to stretch, but also being very muscular and able to, push the kiddo to the outside world. Sorry, I'm trying to see you guys with my little Zoom bar thing, and it is glitching out and like shaking all over my screen, and it's going to make me a crazy person. Okay, I fixed it. Sorry. Anyways, we talked about the uterus, and then we got off topic. We were talking about well, not off topic. That's not true. We were talking about placentas, amniotic fluid, and the amniotic membrane. It was a cool, great questions. But now we're back on track for female physiology today. A vaginal orifice is obviously the opening to the outside world. That's not probably very surprising for anybody there. It's a muscular tube that leads to the outside world. So let's take a look at the production of eggs, because this is really the physiology piece, right? Now, here's where we're going to make one more big difference between males and female in a physiology piece. With the guys, they had one primary spermatocyte that made 4 sperm cells, okay? Meiosis makes 4 cells, so one primary spermatocyte makes 4 functioning sperm, and you make, 270 million sperm later, we're off to the races. Females are going to operate quite differently here. Females are still going to go through meiosis, which is still reduction division, which is still going to give you 4 cells, but she will only have 1 egg. You will form 1 egg from 1 primary oocyte. And what's going to happen with the others is they will degrade and become what's called polar bodies. Polar bodies are not going to go on to become eggs. They'll be absorbed by the body, and the 1 egg, I'm sure there's some complicated mechanism of its particular choosing, but the 1 egg survives and goes on to become the egg that will be eventually ovulated. So her first meiotic division gives her 2 cells. Her second, and she'll get rid of 1 as a polar body. Her second meiotic division gives her 2 more cells. She'll get rid of 1 more as a polar body, and she'll eventually just have 1 egg from 1 primary oocyte. And that's really all I kind of wanted you to know for that. This part you kind of already know about. Mom's got 23 chromosomes. That's a haploid 1N sex cell called a gamete. The sperm cell is haploid. So you got 23 chromosomes from dad, 23 chromosomes from mom, makes 23 pairs or 46, and that's a 2N diploid zygote. So once you get to this guy, the zygote, 46 chromosomes, then you're at 2N, and you've got all the genetic material necessary for brand new baby human. As far as when does the second polar body become the polar, that doesn't matter. Okay, get the idea that you get polar bodies and 1 egg cell, even though meiosis gives you 4 cells. And I am more than happy with that. So that's cool, because if they didn't do that, every single time a woman got pregnant, she would have quadruplets, right? And that's a lot of kids. So anyways, that's kind of how that works. And I think that's interesting. Now, not as interesting as this. This is really interesting. At any rate, here's what you got. This is so cool. It's just so cool. Okay. Here you have primordial follicles. Okay. Primordial follicles are these little bitty cells here that have the potential to someday become eggs. The mom who is pregnant with a daughter is already housing all of her kids' primordial follicles, which is so weird to think about. But about 400,000 potential eggs are in the ovaries of a baby girl who's not even born yet. It's so many eggs, okay? They're not eggs yet. They're primordial follicles that have the ability to become eggs, but just so you know. They're these little bitty cells. They're in the cortex. I don't really care that you know that. Once they appear, no new ones are formed, but like I said, they appear before you're even born, so you're going to have a lot of primordial follicles. Each follicle really has 1 big cell, and we essentially call these primary oocytes. If you know that an oocyte means egg cell, because that's what it means, that, in my opinion, is pretty cool. If you don't know when to differentiate when is this speck a primordial follicle and when is this speck a primary oocyte, nobody cares, okay? But get the idea that there's tiny cells that have the capacity to become eggs later when certain hormones tell them it's go time for ovulation. There are a bunch of follicle cells that surround the primary oocyte, and these guys are downright amazing, like absolutely crazy amazing. But this little blue blob here is going to become an egg. This entire organ here is an ovary. That's kind of the no duh point. I guess I should have pointed that out, but I just assumed you knew at that point. This whole thing is the ovary. The little blue blob is becoming an egg, and it's going through, meiosis and what have you. And we get to a point where it's essentially an oocyte. Okay, an oocyte is an egg cell. Now, the egg cell is important. Don't get me wrong. It's super, super, super important. But around the egg cell are these little tissues, little cells that surround the egg cell called follicular cells or follicle, right? You might remember follicle stimulating hormone. That's the follicle we're talking about, not the is hair growing here out of my hair follicle. The follicular cells, it's makes my mind not understand life anymore. But basically what's going to happen is when this egg cell, this little fellow right here, this oocyte, is ready to go, let's just operate under the assumption, which this is what the textbook would say, but between the very small sample size of, my better half and the few friends who I would consider oversharers, I would say most people do not hit a 28-day cycle to the day. But let's just pretend it's a 28-day cycle. Pretend it's a 28-day cycle. And on day 14, she's going to ovulate this egg. When she ovulates this egg, this is our primary oocyte. There's some fluid coming out, and this primary oocyte is ready to be fertilized with layers around the egg that we'll talk about later. These layers, essentially the sperm cell would have to swim through the layers, and when the sperm cell got to the cell membrane of this egg cell, these layers would immediately become hard and not allow any more sperm cells to get to that egg, which is very cool. But as she ovulates, day 14, the really mind-blowing part of this is these follicular cells, these guys right here, this weird little slug-shaped fellow, is going to stay in the ovary and become the yellow body and then the white body. And this is the cool part. The yellow body secretes localized hormones that interact with the endometrial lining of the uterus and literally tells the uterus, don't have a period because there could be a kid on the way. And those localized hormones make that endometrium stay thick to receive a child if that's going to be the case. Then later, a few days later, the corpus albicans is formed, and that secretes other hormones. And these two guys are working together to make sure that this egg has adequate time to get fertilized, move down the fallopian tube, implant in the uterus, start to secrete, this is the more confusing part, the kiddo. Let's assume pregnancy occurs, right? There's sperm cells in the fallopian tube, pregnancy occurs, kiddo docks the endometrium. Then the kiddo, as it's growing the placenta out, starts to send its own localized hormones out that's like, don't have a period. We need this endometrium right now. Keep it where it is, okay? And then the period is missed, right? But it's to maintain that endometrial lining. And so, I don't know, maybe you think that's cool, maybe not. But for me, the idea that a bunch of little cells that surrounded an egg then communicate to a uterus to maintain the lining of the uterus to make sure no kiddos are accidentally pushed out is like mind-blowingly complicated, and like, that is so cool. What a cool design. I don't know, maybe you don't think it's that cool, but I think it's really cool. So what a sharp design, I tell you. Anyways, so that's an ovary. That's how eggs are made. That's how eggs are ovulated. And I've got some notes on corpus luteum here in a little bit, but just kind of big picture first. So let's see. Hypothalamus goes pituitary gland, says GnRH, go for releasing the gonadotropins. The pituitary gland in the woman this time, because we're on to the girls, not the guys, releases LH and FSH, follicle stimulating and luteinizing. Okay, so follicle stimulating and luteinizing head down to the ovaries and regulate this process of ovulation, which is cool. So the primordial follicles, Basically, FSH is going to cruise down to the ovaries. Again, as far as you telling what's FSH and LH2, I don't really care. Note they regulate ovulation, and you're going to be sharper than the average 17-year-old kid, right? So the ovaries enlarge when FSH is first secreted. So we're talking like puberty time here again. Primordial follicles with FSH, the follicles are going to mature because that's what they do. They stimulate follicles. And so that's going to take these primordial follicles, the cells that aren't an egg yet and have the capacity to be an egg, and say, hey, you know, I don't know how they communicate this. Hey, one of you 400,000 want to become an egg? And one was like, yes, please. And the oocyte enlarges to become an egg. The cells around that egg go through mitosis to become this large covering that will eventually be corpus luteum and corpus albicans, which is pretty cool. There is some fluid filling the space around the egg. I don't know if that's life-changing information necessarily, but as it becomes more filled with fluid and more filled with fluid and more filled with fluid, it's also migrating through the ovary to kind of the end of the ovary where that infundibulum and fimbriae were like sweeping the ovary to try to get that egg, and the egg is going to migrate. This is me not being able to draw on a whiteboard. It's fine. The egg is going to migrate up to the end of the ovary and then ovulate, and the egg comes out of the ovary. And so the follicle fills until it's very, very filled with fluid. And when it's very, very filled with fluid, you're going to have ovulation occurring. You can have many follicles mature at the same time, which is kind of cool. But whichever one is sort of the fastest growing, the healthiest egg is going to mature the quickest and be the one who makes it to the gate for ovulation. So that's kind of a cool thing. The others who responded to that FSH will disintegrate, kind of fall apart, be reabsorbed by the body, and you know, that's it. You've got a storehouse of another 400,000. So to lose, you know, what's 10 or 20, you know, follicles that gave it a shot per 28-day period, that's fine. That's totally fine. So that's kind of an interesting thing. It is a little bit of a race. Not something I know if you need to necessarily commit to memory. I'm not sure how they got this picture. Holy moly, that is so weird. Okay, anyways, here it is. I give you ovulation. Here's the oocyte. It is surrounded by the corona radiata, which means the radiating crown. Okay, there's two layers of cell. I don't want to say cell wall, cell coverings at any rate around the egg cell, and this one you can actually see, which is so crazy, and it's coming out of an ovary, which is so cool. And then here you have the infundibulum and the fimbriae that are sweeping that egg. And so when you consider how zoomed in they are, it's quite a small journey for this guy to make to be swept into the infundibulum. So the odds of him missing are pretty small. But if you didn't know what ovulation is, that's what ovulation is, the production of an egg. That's not true. The emission of an egg from an ovary, that's ovulation. Sorry, I should be clear with that. Okay, let's see. So the egg cell, a large cell, it's a sphere, no duh. There's two layers around it. There's a zona pellucida on the inside, and there's a corona radiata on the outside. This is sort of the last barrier the sperm cells have to push through, and the corona radiata is so cool because it can become hard like instantly. And if there's, you know, 1,500 sperm cells burrowing into this egg at the same time, when one sperm cell gets into that nucleus, the zona pellucida and corona radiata will instantly become hard. And the other 1,499 sperm cells will be trapped in the zona pellucida and corona radiata, which is cool because it guarantees you're not getting polyploidy in humans, which would be guaranteed fatal. And then eventually that corona radiata is shed. The dead sperm cells who didn't make it are shed with it, absorbed by the body. The zygote divide, and you're well on your way to a bouncing baby boy or girl or, you know, what have you. And so that's I think about it. So yeah, I would like you to know zona pellucida and corona radiata. So as far as like, what do I need to write down? Zona pellucida, corona radiata. If I had a whiteboard, it would go egg, zona pellucida, corona radiata. If I had a whiteboard. So just draw a bullseye, 3 circles, egg, zona pellucida, Corona radiata. Sorry, you just have to deal with my silly circular hands in front of my face. That's what I have to work with. All right. Everybody cool with eggs? Weird side note. Don't take this anything as except for a weird side note. You can't talk about eggs without mentioning this. A viable human egg is the most valuable product by weight on planet Earth. It is more valuable than gold. It is more valuable than platinum. It is more valuable than diamonds by mass. There's nothing on planet Earth worth more money than a viable human egg. Just in case you were curious. Like, I don't know why. And I'm sure there's like, I'm not saying you should donate eggs or sell eggs, or you should or you shouldn't. You make your own decisions there. I don't really care. But just so you know, like, that's weird, right? But there you have it. Between $8,000 and $14,000 per donation for something that is immeasurably small. So, holy moly, right? Crazy. Anyways, so now you know. Oh, sorry. What's up, John?
I'm looking at Google that it says they're sold in the United States for anywhere between 5,000 and 50,000.
Oh, my 8 to 14 was way off. How dare I? Sorry, sir. Sorry, John. You can't donate eggs. Anyways, holy moly, man, those things are worth a lot of money. Yeah. All right. Okay. Let's see. Ooh, reproductive cycle. This is the physiology part. We have 10 minutes. Oh, we can do it. Kind of. Maybe. We'll see. At any rate, guys, if you didn't know, ballpark every month, women will bleed, and it's called menses. More often than not, it's called a period. Girls in here already know that. You guys probably do too. But here's how it's regulated, which you probably didn't know. It's all called a menstrual cycle, right? The period term that's super common in the United States is called menses. M-E-N-S-E-S. Menses. Nobody's comfortable with the word menses, so we chose the dot at the end of a sentence. America's a weird, I don't know, whatever. So there you have that. Menses, of course, occurs because for the last 14 days, this lady has built up an endometrial lining with increasing tissue and increasing blood supply to catch a kiddo. She ovulated. She produced an egg. The egg traveled down. No sperm met the egg. No kiddo was produced. The egg traveled through the uterus, and now we need to wipe the slate clean and start all over again. So in the next 14 days, she can ovulate, and we can repeat the process. 14 and 14 is 28. It's probably not going to be that on the clock every single month, but, whatever. So how this is all regulated. By the way, it begins at puberty. Duh. Ends during menopause. It's a different age for everybody, but there will come a time in a woman's reproductive life where she stops producing eggs. Oh, well, I guess that'd be the end of her reproductive life. Whatever. Doesn't matter. Where she stops producing eggs, right? 45, 50, 60, pick a number. She stops producing eggs. Okay. So it does make some hormonal changes and stuff, but basically she's done ovulating. She's done having kids now. So how is it regulated? Some stuff you already knew, some stuff you probably didn't know. The anterior pituitary gland releases LH and FSH. These guys are like our best friends in physiology right now. We know them well. FSH, follicle stimulating, stimulates a follicle. There's a not surprise. The follicle, the primordial follicle, was the little tiny dot who had the capacity to become an egg. So FSH cruises down the bloodstream to the ovary and says, it's go time, girls. Become an egg if you wish. And 10 to 20 of them are like, let's go. I'm ready for this race today. And they become an egg. The follicular cells are going to start to secrete estrogens. This is the most common female hormone. And the estrogens are going to cause the uterine lining to start to thicken up in preparation for catching this new kiddo who's potentially on the way. So that's the reason that's a gross oversimplification. Estrogens do many things. That's one of the jobs of estrogens. If we talked about everything estrogens did, it'd be ridiculous, and it would be the other 10 minutes of this class. And also, I don't know all the things estrogens do, so it's a lot. Sorry, Peyton.
So like people that go through the gender swap or whatever, that like the girls that take estrogen depleting stuff, would they go through this at all, or would that like stop because they don't have estrogen in their body?
the safe answer and the most appropriate answer would be, I don't know. That would be like, that's the most honest. I think the logic behind your question, which is if you pump a gal full of testosterone and knock down the estrogen, is it going to mess with ovulation or stop ovulation? I would hedge my bet towards yes. Great question. But the safe answer is I don't know. But I'm thinking it's going to be a complicated host of complications. But yeah. Good question. Good question. Let's see. Anyways, LH, luteinizing hormone. So LH comes out of the anterior pituitary again, and that's actually going to cause ovulation or the release of these eggs. As far as FSH and LH, if you don't really know which one does which, but you get the idea that these two hormones work together to produce eggs, grow eggs, and ovulate eggs, you're going to be in great shape. I'm happy with that. So just so you know, that's what they do. The corpus luteum is the yellow body, right, is going to develop from the follicle cells. And the really cool thing about this thing is the corpus luteum is going to secrete two hormones, estrogen and progesterone. And this is interesting. And I'm a little bit, I don't know, maybe I shouldn't say that. I'm going to, though. I'm a little bit out of my scope of expertise in this area, if we're being completely honest. But I think it's interesting, and you should at least see the correlation, I think, is, do I want to say most? I do. Most common birth control pills, shots, whatever, right, work with the hormones estrogen and progesterone. And I think you should at least make that correlation because it's interesting, and wherever you sit on that spectrum of your opinions on that totally doesn't bother me. But essentially, the corpus luteum releases estrogen and progesterone. The uterus gets these hormones that says, hold on, stop everything, there might be a kid on the way. So as a result, you're not ovulating anymore. Oh, thanks, Grace and Anna. I don't know if that's accident. They're like clapping hands. It's okay. Indeed. I don't know. I don't know what that's for.
Wait, I meant it to be like a raised hand.
Oh, perfect. That even better. Yes, Grace.
So why is it that like women when they are pregnant, they like get new allergies or like lose allergies? Like my mom's got like bad eyesight or it got better. I don't know. It's weird.
That's super weird.
Why is that?
I've never heard of someone's allergies going away during pregnancy. That's honestly the first time I've heard of it. I'll look it up.
That happens to my aunt too. She has like a broccoli allergy now. And my mom had an egg allergy and now she doesn't after pregnancy.
What?
Yeah.
I'll look it up.
Okay.
I'll make it my homework. That's a good question. That's a great question. Okay. So, and it also satisfies my curiosity of why we were clapping for progesterone. Anyway, so estrogen and progesterone essentially is this. Corpus luteum secretes these two hormones. Those two hormones tell the uterus and the ovaries, don't ovulate, don't have a period, just shut her down, stop, and hang on because there could be a kid on the way. And I think it's fascinating that you're like, you know, take a pill every day for birth control stuff or the weird little matchstick that they cut and put in your skin or whatever are secreting these low doses of estrogen or progesterone or a mix all the time, which I think is a fascinating correlation because basically this gal is taking a pill that tells the ovary and the uterus all the time, don't do anything, don't ovulate, don't do anything, there could be a kid on the way. So she might spend, I don't know, let's pick a number, 5 to 10 years of her life continually intaking hormones that say, stop everything, shut everything down, and hold on because there could be a kid on the way, which is interesting, right? And so I don't know. I think that's fascinating that what the corpus luteum does for a short period of time. We have, as a society, capitalized on that information and extended that out to many, many, many years or fewer years, depending on what the person chooses to do or not do. But that's an oversimplification of essentially what birth control pills are doing. And so for those of you who, you know, whatever, in the future or whatever, are looking at that or looking into that, and you see something odd like, oh, it says that you might have 2 periods a year or 5 periods a year. What is happening? That's why, right? Is your body's getting these estrogen and progesterone. It's like, stop everything. Don't do anything. There could be a kiddo on the way. And it does stop everything for like a while, a long while. And then, eventually the ovary's going to kick out an egg, right? Probably, more than likely. But like I said, I'm outside of my area of expertise here. So take it with a grain of salt and talk with your whatever, doctor, parents, both, all of them, whatever. So back to reproductive cycle. I just thought that correlation was interesting. 2 minutes. Dang it. Okay. Dang it. All right. So you already know this now because we spent so long talking about it. The corpus luteum secretes estrogen and progesterone. These are the 2 most common and abundant female sex hormones. Estrogens are doing secondary sex characteristics just like testosterone was doing for the guys, only different, right? In that girls aren't getting shoulders broader than hips, they're getting hips broader than shoulders, right? And so that kind of stuff. They're different secondary sex characteristics. Obviously, you knew that already. Estrogens cause the uterine lining to thicken, which is to be ready to receive kiddo. Sorry about the terrible underlining. The progesterone is going to stimulate some glandular and vascular growth in the lining, which basically means more blood vessels. Do you have to know which one does which? No. Don't make flashcards like, what exactly does estrogen do in the inner uterus? No. Get the idea. Together, the endometrium, estrogen and progesterone make the endometrium grow and also grow more blood vessels. Lots of blood vessels, thicker tissue, great chance of catching that kiddo when he comes out of the fallopian tube. Or she, whatever, when kiddo comes out of fallopian tube, great chance of catching. When these hormones are in the bloodstream, they are going to inhibit the secretion of LH and FSH, which should, it seems weird, but it should seem logical, right? If the endometrium is thick and we just ovulated, we should probably turn off the hormones that cause us to ovulate. You don't want to ovulate if you just got pregnant, right? It doesn't make sense to ovulate if there's a kid who's just coming out of the uterine tube or is just docking to the endometrium. We don't want to do that. That's crazy business. So, LH. Sorry, what's your question?
What's ovulation again?
The release of an egg from an ovary.
Oh, okay.
Good question.
Thank you.
You want to ovulate, thicken the endometrium, catch the kiddo if there's a kiddo. But when that endometrium is thickening, you shut off the ovulation. We need some time to see if the egg was fertilized to become a kiddo and catch him before we ovulate again. This is the reason for the 28-day cycle. 14 to ovulate, hold the thick lining, reduce the lining, shed the lining, thicken the lining again, ovulate, repeat, 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 repeat until you're 50, right? It's an energy intensive process, but it does a great job. So I really want to finish this slide, but it's 31 and I'm going to be obedient to our time limit. So with that, do you have any questions about reproductive physiology, menstrual cycle, estrogen,